In this video, I'm going to talk about how you can interpret confidence intervals for both mean and standard deviation. The first situation I'm going to look at is the mean. Suppose we have a clinical drug trial for a medication that's intention is to lower LDL cholesterol, and we're really shooting for maybe 10 points. In this study, let's look at a couple scenarios. In the first one, the mean is -2, so we're dropping cholesterol by 2 points on average with a standard deviation of 2. Now this study really, you might not think it's very good. Statistically speaking, you have almost a 16% chance of increasing your cholesterol. So that would be if your change amount is positive. On average, people drop 2 points, but we're really not seeing many people that reach that -10 value that we're looking for. Now, if we do create a confidence interval with that mean of -2, standard deviation of 2, and let's just say we have 50 people in this drug trial, and we set the confidence level to 95%, we're seeing somewhere, we think that the drug reduces cholesterol somewhere between 2.6 and 1.4 points with 95% confidence. So we can't really use the word probability. We don't know what an individual person's probability is. We don't want to use the words percent chance, and we're not really looking at individual people in general. All we're saying is we are 95% confident that the average drop in cholesterol is somewhere between 2.568 and 1.432. So that's how you would interpret this confidence interval. We could perhaps, now this would be statistically significant since that entire interval is negative. We are really thinking that in general, the population is on average dropping their cholesterol. However, it's not really practical to only drop by, somewhere to 2.6 to 1.4 points. So what we would like to see is something where our mean is perhaps closer to 10, maybe even if we got to like a value of 9 for our drop in cholesterol, we'd be closer to where we want to be. And so on this one, for example, we're seeing somewhere between an 8.4 and 9.6 point drop in cholesterol. We'd be getting closer to our value of 10, but you can see that you really need to, because of the dispersion of a sampling distribution, you really want to pass your goal. And so with a confidence interval for the mean, really the goal is, if we're shooting for a 10-point drop to get that entire confidence interval below 10 points. And so we'd want to beat the margin of error. And what we might do is kind of think about what the margin of error is in general on this distribution. And we're somewhere at about 0.57 for our margin of error. So if we go past maybe 10.57, like 10.58, then we can get that entire confidence interval under that targeted 10 points. So really with kind of to summarize this all up, if you have a goal for your population mean and you want to provide some evidence that you've met that goal, you're looking for a sample that really exceeds your goal. In this case, our goal is -10, so we want to exceed that goal and go past -10 by enough points that we exceed the margin of error. And that will put that whole entire confidence interval in that goal range. So another example, we want to maybe meet a goal of 20. I'm going to just not really use as an applied example here. Let's say we have a goal of 20. We've got a standard deviation of 4, and we'll just keep that at 50. If we have a sample of 20, we won't have that entire confidence interval past that goal. We would really want to exceed that margin of error of 1.137. So let's say we shoot for a sample mean of 21.138. And now our entire confidence interval is above 20. So if I wanted to provide evidence that a population mean was above 20, I'd really be looking for a sample that exceeded that past the margin of error to put that entire lower and upper bound in my target area. That's the most common process with putting a confidence interval to use. Basically sampling and trying to shoot past that goal that we're trying to provide evidence for. With a population proportion, it's kind of a bit different. What I'm going to do is go to this election problem. Here we have 24 votes in an exit poll for the winner, Angela, and 36 for the loser of the election, Olivia, with a total of 60 votes. We can see a confidence interval here, and we're going to take a look at a couple situations. In the first situation, I'm looking at 80% confidence, which has a pretty narrow confidence interval with a margin of error of 8.1 up and down from that 40%. And so we have 40% plus or minus 8.1%. We end up with an entire confidence interval below 50%. So if someone's telling me that Angela won the election, I could say with 80% confidence that the value of the parameter is under 50%. In fact, all the way down at 48. And you might be able to just kind of walk this up until you get to that value just below that value of 50%. We're not going up by much, so let me jump up to like 88 here, maybe 89, and that just goes over. So I could say with 88% confidence that Angela did not receive a majority of the votes. As soon as I get to 89% confidence, there is that possibility that she got over 50% of the vote. It may be a low probability, but I could no longer justify a claim that she lost the election. And if I go up to 95% or even 99%, the upper bound is going to go much past 50%. So this confidence interval is somewhat inconclusive. I'm not sure. She could have won, she could have lost. If I take a look at Olivia's vote, it will kind of flip things around. And with 95% confidence, I'd say most of the confidence interval is above 50%, but not the whole thing. Again, it's going to be down around like that 89%, maybe 90% confidence level where I'm going to, oh no, I need to go below. I need to go a little bit lower confidence, make it a little narrower. And now I could say with 88% confidence, I have evidence that Olivia got over 50% of the vote since the entire confidence interval is above 50%. So that's how I would interpret that. There's other situations with the confidence interval for proportion beyond voting. You could talk about like percent of on-time flights, things like that. For different industries, there may be different qualitative analyses that we do. The last thing I want to do is take a look at this applet that simulates confidence intervals. So let's say we have a candidate. I'm going to just reset this here. We have a candidate that got just over 50% of the vote. And I want to see what confidence intervals would look like with sample size of 50. So I'm going to say that the winning candidate got 51% of the vote. I'm going to take a sample size of 60 from that population and do that 20 times. Now here what we see is that we have a variety of point estimates, all around 51%, some above, some below, some close, some a little farther. In this situation, 90% of them contained 51%. The ones in red here had point estimates that were much too high, too far above 51% to get that margin of error to include that population proportion. And if I were to redo this again and again, we're going to be at about 95% of the time on average. And it might help to just increase my number of intervals to 100. And here I'm at 93% accuracy, 92% accuracy, 95. Now we don't like to use the word percent accuracy or percent chance when we're talking about these confidence intervals. All we say is with 95% confidence. For example, if we pick one of these at random, this interval, you would say with 95% confidence, the value of the population proportion is between 27.6% and 52.4%. And that would be true because it was actually 51%. With the red one, we would be wrong. We would be saying, with 95% confidence, the proportion is between 51.1% and 75.5%. And we'd be wrong. We'd be in that 5% that we're throwing out, kind of at the far edges of that curve. And so I think it's interesting to see this, just simulating this process again and again and again. You do miss the mark sometimes, and that's what happens in elections when either your sample is non-representative or, possibly the population changes as the election goes on. If you're doing a poll before the vote happens, you have to be prepared for that to change. You might over or underestimate those votes.